Hello, my dear students. Today we are going to continue our discussion on organic chemistry. We are going to discuss the alkanes and the nomenclature of alkane and the preparation of methane, and we are going to discuss the physical properties of alkanes, and we are going to discuss the chemical properties of methane and its economic importance. So let us start. Saturated hydrocarbons, alkanes. Alkanes are hydrocarbons having the general molecular formula CnH2n plus 2. We have give reason in this point. Alkanes are saturated hydrocarbons because all their bonds are sigma bonds and have no pi bonds between the carbon atoms. The first members of alkane family. The name and structure formula and molecular formula: methane, CH4, CH4. Here, ethane, CH3, bond CH3 or molecular formula C2H6. Propane, CH3, CH2, CH3 or molecular formula C3H8. Butane, CH3, CH2O2, CH3 and molecular formula C4H10. Nomenclature of alkanes. The name of the alkane is determined according to the longest continuous chain and on the number of carbon atoms in it. For example, as shown on the screen, root name is pentane, and here the root name is hexane, and the carbon atoms are given number in the longest chain, and if the longest alkane chain free from any branches or side chain, the carbon atoms are given numbers from any side, left or right. As shown on the screen, it will be normal butane, and another example, it will be normal pentane. If the longest alkane chain attached to an alkyl group or any other atoms, the numbering of carbon atoms in the alkane chain begins from the side which is near to the branch, and the nomenclature begins by the number of the carbon atoms from which the chain arises, then the name of the branch, and ending by the name of alkane, such as shown on the screen. This molecule, its name, it will be 2-methyl-pentane. Here the numbering of carbon atoms start from nearest to the branch. Another example, here it will be 3-methyl-hexane. If the side group is repeated in the alkane chain, we use prefix di or tri or tetra to indicate the number of repetition. As shown on the screen, its name it will be 2,3-dimethylpentane. Another example here, as shown on the screen, it will be 3,3-dimethylpentane. If the branch is a group such as chlorine, bromine, nitro, the name of this group is ended by the letter O, so we say chloro, bromo or nitro. As shown on the screen, it will be 2-bromobutane. Another example, 2,3-dichlorobutane. If the side groups are different groups, such as alkyl or halogen, the groups are arranged according to their alphabetic Latin names, after numbering from the end, that giving the branches the least possible summation. For example, here 2-bromo-3-methylbutane. Another example, as shown on the screen, it will be 2-bromo-3-chlorobutane. Another example here, 3-ethyl-2-methylpentane. Another example, 2-bromo-3-ethylpentane. Another example, as shown on the screen, its name it will be 2-bromo-2-chloro 1,1,1,trifluoroethane. Now we are going to discuss the methane molecule. It represents 90% of natural gas under the Earth's crust or accompanied to petroleum. Methane gas is called the gas of swamps, and we have give reason in this point. Because it goes out as bubbles in swamps produced from decaying organic wastes by bacteria. Methane gas is found in the atmosphere in a small ratio, 0.00022%. Preparation of methane gas in lab. The name of the preparation of methane gas is called dry distillation. So this process is done by using anhydrous sodium acetate with soda lime giving methane. The soda lime here, my dear student, is a mixture of caustic soda, which is sodium hydroxide NaOH, and quicklime, which is calcium oxide CaO. As shown on the screen, the heating of mixture of sodium acetate and soda lime gives the methane gas that is collected above the water. As shown on the screen, the soda lime is heated with anhydrous sodium acetate, and the methane gas is collected above the water in the jar as shown on the screen. So the equation of the reaction CH3COONA plus NaOH in the presence of calcium oxide and heat gives methane CH4 and sodium carbonate is produced. So we have give reason in this point. Using soda lime is better than caustic soda in preparation of methane because calcium oxide reduces the melting point of the mixture and absorb water vapor. Another give reason in this point, methane is collected by downward displacement of water because methane gas is lighter than water and also it is insoluble in water. The physical properties of alkanes. The first four compounds are gases from C1 to C4. Methane is a fuel for houses. Propane and butane compressed in cylinders and used as fuel in houses called butagaz. Notice that, my dear student, in cold places propane ratio increases than butane, and in hot places butane ratio increases than propane. Alkane contain 5 carbon atoms till 17 carbon atoms are liquids of low boiling point as kerosene fuel. Alkanes that contain more than 17 carbon atoms are solid as paraffin wax. Alkanes are insoluble in water. The reason for that, because alkanes are nonpolar compound. Metals are covered by heavy alkanes such as paraffin wax or kerosene, and give reason for this point because they insoluble in water, so protect the metals from oxidation and rusting. The chemical properties of alkane, my dear students. We have give reason in this point. Alkanes are chemically inactive and don't react with sodium or oxidizing agent because they have all the sigma bonds are between the carbon atoms, which is strong and difficult to be broken, as the following animation show. As shown on the screen, if we put potassium permanganate that has violet color in the methane gas, we find that the color of potassium permanganate remains. That means it doesn't react with potassium permanganate. Now we are going to discuss the burning, which is combustion with oxygen. Alkanes burns in oxygen, giving water vapor and carbon dioxide, releasing large amount of heat. Here, the collected methane gas on burning, yes, it gives carbon dioxide and water vapor as shown on the screen. So, my dear student, These reactions are highly exothermic and used as fuel. As shown on the screen, the equation of combustion of methane, CH4 plus 2O2 gives CO2 plus 2H2O plus large amount of heat. The halogenation reaction. Alkanes react with halogens fluorine, chlorine, bromine by heating up to 400 degrees Celsius or in the presence of ultraviolet rays in series of substitution reaction, and the product depends on the ratio between the methane and the halogen in the reaction mixture. As shown on the screen, CH4 reacts with the chlorine molecules. Here the carbon is bonded by 4 sigma bonds between the carbon and the hydrogen, and the chlorine molecules, the 2 chlorine atoms, are bonded by single covalent bond. Here the reaction done by breaking one of the CH bonds and formation of CCl bond instead, and HCl molecule is produced. So we substitute the hydrogen atom by the chlorine molecule. So the equation that proceed on the screen, CH4 plus Cl2 in the presence of ultraviolet rays or 400 degrees Celsius gives CH3Cl plus HCl. The name of the produced molecule is methyl chloride or chloromethane. This chloromethane or methyl chloride reacts with another chlorine molecule in the presence of ultraviolet radiation and forms methylene chloride CH2Cl2, releasing one molecule also of HCl. Remember, my dear student, methylene chloride can be named dichloromethane. Another further reaction occurs. The methylene chloride reacts with another chlorine molecule in the ultraviolet rays, forming trichloromethane or chloroform CHCl3, releasing one molecule of HCl. And further reaction occurs by replacing the last hydrogen. When the chloroform reacts with chlorine, it gives carbon tetrachloride or tetrachloromethane as shown on the screen, releasing one molecule of HCl. Now we are going to discuss the uses of halogenated derivatives of alkane. The name and the formula and the uses. The chloroform or trichloromethane, its formula CHCl3 or structure formula as shown on the screen. Here its use, anesthetic substance, but its use was stopped because the inaccurate estimation of the dose for each patient caused the death. Another compound, halothane or 2-bromo-2-chloro 1,1,1-trifluoroethane as shown for structure formula on the screen, or molecular formula CHBrClCF3. Its use is anesthetic substance that is used now safely. Another compound, 1,1,1-trifluoroethane as shown structure formula on the screen, or CH3CCl3. Here it is used in dry cleaning. Another compound which is ferrion. Here another example here. The ferrion has two examples, CF4 or CCl2F2, which is the most famous type. Its use in air condition and fridges, and rushed substance to liquid and perfume, and the cleaner for electronic sets. So we have good reason in this point. Ferrions are used in large quantities as cooling agent. Due to its cheap price, easily to be liquefied, non-poisonous and no corrosive for metal. My dear student, there is an international agreement to prevent the use of ferrions in starting from 2020, because ferrions cause the decay of the ozone layer, which protects the earth against the harmful effect of ultraviolet rays. Now, my dear students, we are going to discuss the thermal catalytic cracking process. It is converting the heavy long-chain petroleum to lighter short-chain products. We use the long-chain petroleum product, the carbon atoms here linked by single covalent bond. By the presence of high pressure and pressure, this bond is broken and forming two molecules with short-chain carbon atoms, as shown on the screen. So, my dear student, this process takes place during refining petroleum oil to obtain gasoline for car fuel or ethane and propane in the manufacture of polymers. This process takes place by heating the heavy petroleum products under high temperature and pressure in the presence of catalyst. For example, my dear student, C8H18, which is octane, by thermal catalytic cracking under high temperature and pressure, it produces butene C4H8 and butane C4H10. Now, my dear